Hey, this is Steven from the Green Engineers, and welcome back to my update videos. We're here with the Reclaimer, which is my 6-inch wide by 6-inch wide by 3.5-inch tall plastic shredder. So we're going to go into talking about this guy here. I'm first going to put out a few disclaimers to some of my some people that have early backed it. Originally, I sold this guy to a few people at a price that was, if I made it, and I did go about trying to make it myself on machines at my local community shop called Tech Shop. Tech Shop went under November of last year, and it's been almost impossible to make it myself ever since for the price that I originally wanted to make it for. So right now, in the meantime, while I'm working on getting those guys their shredder or getting this alternative method, this guy is going to be going up on my website. I just contacted a water jet company. I would like to contact some other companies as well to see if I could get a better price, but overall it was looking at like it was like $420 or something, like $420 to make this guy. If somebody else makes it, that would be the price, and made in 4 to 5 days for them to cut it at this water jet company, to get it to me and for me to build it. So I'm going to probably update that price if you guys want to get it quickly. If not, eventually originally the new shop called The Shop .build is coming to San Jose, and theoretically they're supposed to have a plasma, the water jet, and a fiber laser. And this guy, the idea is to run this guy cut with a fiber laser, or I wanted to put my hand at building a home water jet to cut this guy, because at Tech Shop they charge an additional rate for those machines because of the high power. And I have somebody here at my place that wants to run this stuff for me. So if I have a machine, I could have them run it, and so that's what I might do. I might get myself a little CO2 laser here, maybe a little router, and maybe build a water jet to cut this guy. Anyways, more about that later. I will talk about that at a later date. This is just kind of saying that I am working on it. In the next update, we'll talk more about it, and in that update will probably be when this guy's running. So, as it's not quite running yet, because I need to have a mount here on the sides to mount it to a table, because that's how it was originally designed. Or I'm going to build the optional part for it, which is an optional a floor mount, which is like a stand, kind of like this, where it's on a steel tubing stand, and then you slip a bucket underneath it and it grinds into a bucket. And then I have to work on the cowling that goes around it, or the hopper for you to load all your plastic in there, so you can load quite a bit of plastic in there. And then I have to add a motor option. But currently, at this point, it is manually operated. I'm probably going to stick a nut or a bolt on here so that you could use a big breaker bar, or you just use a socket or a giant crescent wrench to turn this guy. So inside it has 24 teeth. Each tooth is 1/4 inch width, and the tooth protrusion is about 1/2 inch. The mouth here is about 6 inches by 6 inches by 3.5 inches tall. And the cut from here to here is about 3.5 inches or so. So the actual piece that I could chomp down on, let's say if it's a rigid piece of plastic and it wasn't like a milk jug that won't just flatten, it could be about 3.5 inches of rigid plastic wide, and then the whole 6 inches wide this way. So it's a 3.5 inch by 6 inch kind of cut. If it's thin plastic, it'll just crush it as it goes in there, and you can kind of put bigger pieces in there as long as you push it down at the top. It's got these gears here. These are tapered tooth gears. This was actually water jetted at my university, and I was doing a test on that water jet at the university, and I was seeing if it could do 0 backlash gears. Didn't think that that was going to happen. I thought that it was going to be undersized. In actuality, the machine did perfect 0 backlash gears. And what that means is that if you would look at these gears, when it goes between the two gears, it will have it will contact here as well as on the inside. So if you'll see down here, can't really see it, but there's a contact point here and a contact point here. So there's a contact point in here with the next tooth and a contact point here with the previous tooth. So what that means is that there's no room for this guy to move like that. It's super tight. So normally you'd have some movement. Obviously completely useless for this. I wanted to see that if I had the university, because I'm going to be there for one more year. This next year is my last year. Because I'm going to be there for one more year, I wanted to see if it was going to be able to make precision machine parts for building a machine that has to be precise. In this case, I'm probably just going to take some of these. These are 1055 gears, which can be hardened. This guy's an 836 gear. I'll probably just sand the crap out of this one and stick that one on there, and then take that one off. So because everything in here, besides a few things, all the teeth and stuff, all these what I call quote-unquote half moons are 836. The spacers on the inside, which there's 24 of, which are down in there inside, those are each also 1/4 inch 10. Those are 836 as well, because they're not going to need to be hardened. So here we're going to take a quicker look so you can see down in there. There's the spacers, and then these are the half moons. These are not bolted down, welded down, or anything. These are actually moving. You can hear that they're kind of free to move. So that's kind of the situation right now. And then I added, so this whole thing is cut out a 1/4 inch sheet or plate, I guess you could say. And one thing I added is what I call the bra, which is this guy out here, and then this guy supports the bearings that are inside. I can't remember what exact size those bearings are, but I could rotate this guy around and I can show you the bearings on the back side. So here's the bra with the bearing pressed in there. It's a 6006Z bearing, and then this guy is pressed in there beautifully with the beautiful precision of this water jet here. This guy just slid in there with an arbor press. And then on the side, it's just spot welded there down the side, so super easy, goes together like Lego pieces. I might even, eventually when I'm cutting my own, I might just even make it a kit where sometimes some of these are out of tolerance and you have to file the square on the inside. And also another thing, inside there's a circular spacer that turns a square into a circle. And so eventually I'm going to have two, because this bearing is 1/2 inch thick. So I'll have two in there on both sides. Right now I only have one. So I might even have it where it's a kit that you put together. Another thing that I need to do is I need to spot weld this guy. Put a spot weld here, spot weld here, spot weld on the bottom, spot weld these bras on. So that'll be an option as a kit. You take it home, you spot weld it yourself, save yourself a whole bunch of money in my time assembling it. One thing that the water jet guy made a mistake on, and he did do it right in front of me, but I didn't notice when he did it, is that when these blades are supposed to be indented. So what I mean by that is that if this is your blade on one shaft, there's dual shafts in there, and this is the second blade, the second blade's supposed to be indented slightly like that, about 15 degrees each blade. Now what that does is that when you're turning the shaft, both blades won't engage at once. You only have to apply enough force to get one blade to cut, and then you have to apply enough force for the next blade to cut. So it's a nice consistent turn, a nice consistent force that you have to put in order for this to work. But when he put this into the OMAX water jet, which is what we have at our university, he just took one of my shredder dials and arrayed it 24 times, made 24 copies. So now you can see the only thing that I was able to do with that, in order to keep them all from engaging at once, was to have one at 90 and another one 90 orientated this way. Because basically each of these blades, the blade, I'm not actually changing where the teeth are, I'm actually rotating the square on the inside. I'm indenting the square 15 degrees for each blade. So that didn't happen, so when I try this out, when you see the first video of me trying this out, I'm going to have to apply a lot of force in order to get this guy to cut. But that will be pretty soon. You'll see that video pretty soon of me doing that. So other than that, that's pretty much it. Super simple. It weighs about 23 pounds worth of steel. Super heavy, but other than that, really easy from my design to assemble and get it to start working and getting it to crush. Obviously, because it's zero backlash gears, there's a lot of friction there, so that's what I need to fix before I can get it running. Alright, we're pretty much out of time. This has been Steven from the Green Engineers. I hope you guys like this video. Please stay tuned for more update videos, and I'll see you guys next one. Thanks for watching. Take it easy. Peace.